get it all down to the science, nobody be able to tell you nothing about it, you'll know it inside and out. You got a learning curve you go through there, once you get through that learning curve, that's a way to build a strong operating group. That's so many times, that's probably about 70% of failures is people operating the machine that really not that familiar with it, and that's not a knock against the operators or anybody. You don't have operators these days. Most of the time you got younger guys coming into the fold, they don't know, they go over and mash a button, it don't come on, well, we'll reset and try it again. You know, they don't have an operator. They go over and look, and there's fire flying out something over where it started, but it just ain't ready in the control room. You're like, oh, cuz, I'll mash that again.
All right, we're gonna go, we're gonna eat lunch about 11:30, so we're gonna go here in a little while. And Curtis said, you got any questions, don't be afraid to ask him, because this is the place to get it answered. What we're gonna do after lunch, we'll go over to the mill. And did everybody bring the PPE? Or get some? All right. Now we'll go over to the mill, we'll go over to 19, let Curtis walk around those 2 turbines over there. We'll spend probably a half hour over there, we'll just kind of touch base on some things if you need to touch base while you're on site. We'll go to 20, spend 15, 20 minutes on that turbine, whatever we need. Then we'll go over there to the paper board conference room. If you have any final questions, that'll be the place to answer, for Curtis to answer them. You know, you might see something out on the turbine that you want to ask him once you get back in there. So.
And please, if you got any questions, just ask. If I don't know the answer, I don't know them all, but if I don't know the answer, we can root you up a legitimate answer. Normal idles or slow roll speed depends on the size of the machine. That's what we were talking about earlier. You know, smaller machines generally require 30 minutes to warm up 500 RPM. While larger machines might have to be slow rolled for 60 to 90 minutes. You know, that's what we were talking about earlier. The smaller machines, you can get away with 30 minutes. But you need to, on the larger machines, once you start getting into the multi-stage machine, and typically speaking, a small multi-stage machine is you're trying to get a lot of horsepower out of minimum space, and they're trying to cram everything in there, and then you end up with a long spindly shaft. We have some machines like a S8 machine. It's 8 stages, and it ain't big around as a 5-gallon bucket. It's just long, and it looks to everybody like a feed water pump. I mean, that thing, you got to roll it for a long time. So it really depends on the machine, but typically speaking, the shorter the machine, the shorter time you need to warm it up. Longer the machine, you need to go a little more. Refer to the manufacturing instructions for correct warm-up time. Slow warm-up speed is necessary to allow all turbine internal components time to heat up and expand. If the operator does not give the turbine sufficient time to warm up, the turbine will experience uneven heating causing vibration and possible internal damage. And that's exactly what we talked about earlier. You know,
If you try to start it up too quick, well, could it also shut itself down?
oh yeah. Most of the time when the turbine shuts itself down, it ain't good. It'll pick up a rub, you know, and when it picks up a rub on a labby or a carbon or oil seal, and it shuts itself down, it'll go to shaking bed, it'll quit. And you need to bring it up slowly. You need to get the heat in it and get it as close, like they were saying, get the internal and the turbine case temperatures and all as close as you can. Reduce the gap in between. Get them close to the same temperature as the inlet steam and the internal part. So therefore, that reduces the amount of deflection in the shaft. It gets everything at the same temperatures and operating conditions.
Well, if you're having vibration, are you getting shavings in your oil?
Now, if you're having vibration on startup, you either got water coming through the inlet line, or you've got oil temperatures too low, or you got a bow in the shaft. And there, when you have a bow in the shaft, you'll pick up rubs. It'll be one of them. You know, if you have shavings in the oil, it ain't gonna run long no way. It'll get real bad pretty quick, cause that old babbitt will ball up, and that's the end of the line. That's when you had to pull shafts and cut journals and coat. And a lot of our newer machines are more tolerant of foreign objects in the oil, because we do coat the journals. We'd rather, if we use a kilo bearing, It's either changing the rotor. We coat our shafts with a HVOF coating, which is a high velocity oxygen fuel with tungsten carbide or something like that. And if you have a bearing fail on that, you can scrape the babbitt off of it, hit it with a scotch right and go, put a new bearing in it. But, no, typically that, I think to answer your question there, if you have contaminants in the oil, it's gonna progressively get worse and then it's just gonna quit.
I don't think the oil stays hard long enough to worry about getting contaminants in it. If it drain it, it must try to get water out of it.
And like on 19, well, that's one thing I addressed on 19, we need to put an air purge system on the front thrust in bearing housing. Put a 1/2 pound instrument air purge on there, coming in the top, and it does away with that rain force. You can increase the flow pressure in there till you start seeing, you can take it up as high as till you see oil start coming out the seals, then you need to back it down. But, during the warm-up time, all casing drains should be checked, and if free from any moisture, they should be closed. That's a big debate with every turbine manufacturer and each individual person. I like running, like I was telling you earlier, when I start a machine, I like to make sure you're not getting the flow through the machine until you're up and loaded. If you keep drains open, the better off you are, until you get full load on that machine. And then you can go to closing. But, the steam traps are installed, make sure they are working correctly and no water is left in the turbine. Also during this time, as the machine uses a turning gear, this device can be turned off. Well, typically, you don't have machines with turning gears on, they typically kick out anyway once the machine rolls off. Back, they keep revisiting the moisture issue, so. Turbines that have a trip and throttle valve installed, how is turbine speed increased during startup? By pressing run on the governor, by quickly opening the turbine governor valve, by latching in the trip throttle valve, by slowly opening the throttle valve. It's by slowly opening the trip and throttle valve. And I can tell you on these throttle valves, which picture was now, when you latch the throttle valve up to check the operation of the trip part of it, you know, and you got it all the way closed and you latch it up and you go open it. I've seen a lot of customers go to check that function, the trip capability of the valve, and they only, once you latch up and you start opening the valve, they only open the valve minimum and try to trip it. Well, they don't hear it slam shut, so they're not thinking it's working. You're better off to go ahead and open it up and then don't backseat it, bring it back a little bit, and then trip it so you can hear it slam shut and make sure it's working right. I flew to Jamaica one time just because of that, which that's understandable over there. What is the purpose of running the turbine at idle speed? To give the operator a break during the startup process, which that could be part of it. To make sure there is sufficient oil supply to the bearings, to make sure all water is moved in the turbine case, to make sure the turbine internal parts are evenly heated and expanded. It's gonna be the last one, you know. You could also include make sure all the water is moved in the system. As far as the oil supply, you need to make sure of that before you roll it off. So. When do you close all turbine case drains? At the turbine idle set point, at the turbine critical speed set point, when all water has been removed from the turbine casing, when the turbine reaches minimum governor speed. It's gonna be the third one, when all water has been removed from the turbine casing. It's just, so many times people they get tired of listening to the drains. I get tired of listening to them too. I can't hear calls of them. And they just go there and shut them. So they don't have to listen to it anymore. When it's really not ready to it's not ready to light off and go, you still got water there, so. Then you got production and all, when you ready to, when you get her up and going, so. Once the turbine is up to slow roll or idle speed, the gland sealing system can be placed in operation. Gland sealing systems are typically only installed with condenser type steam turbine. Their purpose is to prevent pulling air past the steam seals into the turbine exhaust and into the main condenser. Y'all are all back pressure machines over here, so do you have sealing steam on your machines? I don't know if they do or not. I don't think they do. Probably run it through there and people will start, but what that does is induce steam into the packing glands on each end. It creates a vacuum and pulls it off into the condenser, which condenses the steam. People leave those on when the machine is down, and it's just blowing steam in on the packing glands, and it'll eat up a shaft, and it'll put a bow in it, and it's, a lot of people run into a lot of problems with it. But I'm not sure your machines are equipped with them. We'll look when we go, I can't remember, they all run together sometimes. Gland sealing system prevents the flow of non-condensable gases into the main condenser. It provides a barrier steam in the gland area to prevent air leakage into this turbine case. And that basically gives you a layout on how it does and how it operates, and it's a lot like buffer gas, you know, it's just another barrier to help prevent leakage. And sealing steam for a condensing unit should never be turned on when the rotor is at rest or on turning gear. The hot steam on one side of the turbine shaft can cause a temporary shaft flow, resulting in high vibration. Basically gives you a little idea of what it'll do. International Paper in Pineville, Louisiana is a big customer of us because they've got gland seal system on their machine and they won't shut it off. They're a new rotor about once a year. So. When should the gland sealing system be placed in operation? At any time prior to starting the steam turbine while the steam turbine is on turning gear, after the steam turbine is actually started. That's the last one. How does the gland sealing system prevent air leakage into the turbine? Providing a barrier of steam. Like I say, I can't recall if your machines are equipped with them. We'll have to look when we get them. After the machine is slow rolled for the required time, raise the turbine speed to the normal operating speed. While the speed is increasing, if any varying temperatures or vibration levels start to rise, lower the turbine speed back down to a level in which these two parameters are within limits. Allow the turbine additional time to warm up, and the temp speed increase again. If either one of these parameters starts to rise immediately, failure to do so could result in severe internal damage. This is, you have no really no means of monitoring vibration or temperatures on startup. So you're pretty much relying on feel and listening and looking at the thermometer. You know, I do this a lot, so I have my own. I have a little handheld, and they're not very expensive monitors that I can go as we're starting up and put on these machines that are equipped with electronics. I can put on a barrier cap. I can tell you what it is at this RPMs, and we record it. And there's every 500 RPMs, I can go there and check it. You know, instead of going up there with the old nickel trick. You know, many times in the past, the people used to put nickels on bearing caps. As long as it stood up there, you were good. If it fell over, you need to run. So. this speed increase, be careful to avoid any critical speed ranges. And that's what we talked about earlier. You know, you can look in your books and it'll tell you what the critical speed is on the road. And, stay away from it, get on one side or the other. Avoid any critical ranges that might be inherent to the design of the machine. Allowing the turbine to operate in this speed range will cause damage to internal components. Acceleration should be increased rapidly through the critical speed. You know, it's, like I say, you can't get nervous and stop. You got to go. You know, you'll see, and y'all probably experienced that going through a critical. It'll go to shaking and go bananas. You think it's getting ready to come apart. But once you get through there, it'll come lay back down.
Can't we have a book that has these speeds in it?
Do what?
Do we have a book?
It has those speeds in it?
Yeah.
All I know that you got, and I don't know how valid they are, because I think it's just modifications over the years, some of the stuff is pretty old equipment. We were able to find some operating manuals on some of these turbines, and I think about all of them. But I don't know that, if you go through and look at it, because I'm not a turbine guy, I don't know what's going on, but if you go through and look at it, you see somebody wrote a note here, somebody wrote a note there. That information you should be able to get that information. Where we get it, I'm not sure. Check with Anthony, I guess.
Well, he's got new manuals for those two machines on the vacuum pump turbine, the Semo 3 ATK and the 1TS4, the line set turbine.
Well, that's probably your best resource for that.
He's got two sets of manuals for each. Matter of fact, he's got one set that he keeps in there, and then he's got one that I dig through. With my hands, but thing got grease all over them.
We ought to have a copy of it laminated, but they're somewhere around the turbine.
Well, I'll tell you the best thing to do. If anybody's got any questions or any suggestions, you write them down and give them to us. What we do is, like Greg, do just write that down for me, and I'll see who has to see what we need to do about it. Because the information, if the information's out there and it'll help you, then we need to try to get it for you.
Here we go with a typical tripping throttle valve. T&T valves are most commonly referred to. The young people in the South, we just cut words down as minimum as we can. Cut syllables. But anyway, once the turbine is up to operating speed, open the tripping throttle valve fully. Then close the valve a quarter turn. And I don't know if y'all familiar, when you open the throttle valve and it comes all the way up and it's back, what we call back seated. That's when the disc is all the way up against the top of the valve. As the valve gets hot, you're gonna have thermal growth in the valve body and the valve stem. Well, naturally your valve body is larger, so it's gonna grow more than your stem will. So what that does is puts a pressure on the back side of the valve disc, the trip disc inside, which is connected to the stem. When you do that, there's only a small connecting point where that disc hooks in, and it'll cause the valve to stick, and it won't operate properly. It's harder to trip because it's got so much pressure on it from the thermal growth, and it'll damage. I've seen discs come off and shut, but the linkage is still wide open, and you can't figure out why the turbine won't go. Well, your trip disc is broke off and it's stuck down and it shut all your steam off to your machine, but the latch is still in the latch position. Also, adjust the water flow to the oil coolers to maintain 120. That's, here we go, we're back up to that again. You know, I'd keep it in the 140, 160 range. And, I mean, won't get that, about 3 times I've contradicted that. That's one of them click on and drag kind of tests there. See what we're gonna do. Get that out the pile altogether. The turbine is now ready for normal operation. If this is the initial turbine startup or startup after a long shutdown period, it is important to test and verify that turbine OSB trip systems are operating correctly. You need to And we talked about that earlier as well. You need to make sure all your safety mechanisms and trip mechanisms are in place. Your pressure switches, your trip latches, your linkages, make sure they're working free. And all that needs to be operating properly. And that gives you a little illustration of that's what I'm talking about with backseat of valve. If you unscrew it, if you load that all the way up, that disc is up against the top of the valve cap itself, and it just puts a lot of pressure on it. So when you back it back a quarter turn, it gets it down a little bit and lets it free itself up. Before testing the overspeed device set point, check to make sure that the driven equipment such as pumps, fans, compressors are capable of running at the turbine overspeed setting. There's so many times I see customers trying to overspeed, the machine's still coupled up. If there's any way possible, you need to uncouple it. I know on 19, because of the way the speed pickup is, looking at the gearbox instead of the turbine, you had to keep the gearbox coupled up. So, and a lot of times your driven piece of equipment, such as a pump, a roots blower, a fan, can't take what the trip speed is on the turbine. And that's when you start taking impellers and vanes and stuff out of the driven equipment. If not uncoupled, the driven equipment from the turbine to then proceeds with the test. Generator drives can typically stay coupled as long as the generator is offline and not producing voltage. So it's basically pertains to mechanical drives, which that's what y'all have, is that all the driving the paper machines and stuff, but need to make sure. And we could do away with 19 turning the gearbox. We had to disconnect section of the line shaft and turn the gearbox if we go ahead and put that speed pickup on the turn shaft. And you know, that's a smaller coupling undo, that would decrease downtime on doing the overspeed test, because you just busting the coupling right here instead of taking loose all the other stuff, and you're not turning your gearbox 5,000 RPMs, or whatever the trip speed is on it. To conduct overspeed tests, refer to the manufacturing instructions for your machine. General practice requires the turbine to be brought up to its maximum operating speed prior to conducting the test. And what we do on that is we bring it up to maximum governor, all she's going to do. And then you override the governor. And on a lot of electronics, you have overspeed test red button that you mash, and then it keeps increasing speed until your mechanical takes you out. Until your mechanical overspeed trip takes you out. A lot of times your electrical, you have to change the parameters on it, because it'll take you out most of the time 500 to 1,000 RPMs less than what the mechanical does. So you had to get the instrument guys to make some adjustments there. And then once you do a mechanical trip 3 times to make sure it doesn't trend, make sure it's hitting where you need it to be. Then you need to come back and do reset your electrical trip and test it to make sure it's back in this right parameter.
Is that why, because of those trips like that, is that the reason when we're doing trip testing, it takes most of the day to do it?
Mm-hmm. Yeah.
Because I know it's a long process.
Yeah. But I tell you, that's an important feature of the machine. A lot of times, a lot of these, right here not too long ago past, they were, all the big utility plants were taking all the mechanical trips out. They were solely relying on electric. And that's, we'll see how that works out for them. I don't think they've been in place long enough, really. But, I like to have all the safety mechanisms in place I can have between me and destruction. At this point, use the governor's overspeed test function. That's what I was referring to a few minutes ago. To raise the turbine speed to the design overspeed set point. On your mechanical governors, which down on the left, so PG got type governor that sets up straight on the front end. You have the red knob up top. What you do, once you're up at maximum governor, you unscrew that red knob. Underneath there's a little lobe, have a hole in it. And you can't see it, but on the outside of that red knob, there's a little pin that fit in that lobe. And you stick it in that hole and you roll it slowly, and that takes it right on the overspeed. But after it overspeeds, you need to reset that lobe back. If not, when you get restarted again, you need to go right to trip speed again. I've seen that happen quite a few times. Had to fly to a plane because it said as soon as they put the turbine on it, go right to trip speed, you couldn't control it well. The load was flopped over. Somebody stripped it out and didn't reset it. On the electronic governors, they're a whole lot easier to control. They're more exact. You can, you got to hold the overspeed button in. That's the overspeed override test, and increase the speed. You can increase it 1, 2, 3, 4 RPMs at a time. I don't know. The turbine does not trip at design speed, and adjustment will have to be made to the overspeed trip device. The turbine speed should never exceed 2% of the design overspeed set point. Whatever the design overspeed is set at by the manufacturer, you shouldn't go 2% above that speed. If you go above that, typically you'll start seeing on the outside of the turbine wheels where they have a shroud band that holds the blades in, you'll start seeing the shroud band pick up off of the blades. You can look between you should have 2 to 4 thousandths clearance between the shroud band and the top of the blade. You'll start seeing it wanting to rear up. It'll start pulling away. It just wanting to scatter, what it does when it gets up to a speed like that. So that's why we tell you 2% above trip speed. You get the trip speed, you know, a lot of times you need to go ahead and figure what that 2% is above trip speed and get it in your head. So as you bring the machine up, you can go on by it a little bit to see if you're, you know, within parameters and you're close, or give you some idea what you're shooting at. Overspeed set point should be checked at least 3 times. The result of each test must be repeatable within a few RPM, and must also fall within the manufacturer's recommended tolerance for particular type of overspeed device. Non-repeatable test results that show steady increases or decreases should indicate possible failure or fatigue of components. On these, the one on the right is the Turbine style, Worthington. The rest ran on Worthington, Turbine, Terry, Murray, Copus. We own just about everything except for the G and the Westinghouse. And we have, one on the right is typically our design. You have a weight, you have a bushing in the bottom, you have a spring, you have an adjustment screw which is on the top. That's how you adjust the trip speed. And then you have a set screw that'll lock that adjustment screw into place. The one on the left is typically a Terry design, where you have a trip disc. Same principle. You adjust this nut, see the spring, and then you have a nut on the right side. That's how you adjust the speed, by that nut. So, typically you see on this type on the right side, if you start seeing problems with it, most of the time it's right in this area. So many times people just look at it and say it's all right. But where that stem goes through this bushing, it's very small. And it doesn't take a lot getting in there before you start seeing galled in it. You'll start wanting to gall, and then it'll bend in that area. So it needs to be taken all the way out of the governor cup and inspected all those components. And just reset your speed. You should have about 187 thousandths travel on this weight. This weight that's about what it should be between the back of this weight and the top of that bushing. You can check that by spinning around, take your long Allen wrench and push on the back of it and make sure it comes out somewhere in the 187 range. One on the left, typically we just wedge them up, take a big long screwdriver and wedge them and work them. You see that starting to not repeat itself or give you trouble. It has a pivot. See the big slotted screw? there's a pivot point right there. A lot of times you get wear in it and that weight will want to shift around. It's hard to, once it does that, you gotta take it out and put you a new one in. Those springs have a life to them. They're set, each spring is set for a different speed range. They'll color code them. They'll have a green stripe on it, a yellow stripe on it, and I have, in the repair side of it, I have little spreadsheets that tell me what speeds these springs are for. But they need to be taken out. They have a life, most of the time, once a year or once every 2 years, they need to be taken down. Because what you do, you lose the free length in your spring, and it'll start tripping lower. I don't think we're gonna be able, let's see. When testing overspeed system, turbine speed should never exceed what percent over design overspeed set point? 2, 5, 7, or 10? Typically, the way you, if you don't have a book readily available to tell you what the trip speed should be, typically on the, where I showed you the PG governor, the tall governor, most of the time that's 10% above running speed. And then on electronics, it's 15%. Like if you like on the tri-sense, it's 15% above. That to give you some idea where you need to be. You figure what run speed is, and then you can get 10 on the mechanical drives and 15 on the electronic drives. And anything, once you establish that 10 to 15%, then you can figure 2% on top of that. That's your maximum speed that you want to take that machine. But I have some machines that go from 0 to 16,000 in 12 seconds. You know, and it's kind of hard to catch them, and you got to pretty much have that in your mind when you get ready to light her off, but they go pretty quick. Turbine speed test should be conducted a minimum of how many times? 1, 2, 3, or 4?
3. Is that a year or?
Dress Ramp recommends checking mechanical trips once a year, and they need to be done 3 times. That way you don't have any trends. You know, you make sure it's hitting within. And again, you got to remember you're dealing with springs and weights, so it's not going to trip exactly on the RPM. You know, sometimes it'll swing 20 or 30 RPM, but if it stays right in those parameters, you pretty much. In most cases, the complete operation of turbine and function of the control system is designed for. The control system is programmed to follow the starting, stopping, and loading procedures as they are outlined in this course and are normally designed for optimum efficiency of the plant. It is the operator's responsibility to understand these system parameters and operate the turbine in a safe, efficient manner.
Wished we had it.
You know, a lot of plants are, they realize, and they're starting to bring us in a lot and talk with the operators, because that is you know, if you guys run those machines, and you can really extend the life of them and take care of them. So many operators don't know, well, if I don't turn that off, it's not going to do this, or it ain't going to do that. Or if you understand the mechanical side of it as well as the operating side of it, it lets you know, if I don't do that, it's going to affect them seals over there, or it's going to affect that rotor. And loading procedure to steam turbine depend on the type of machine and status of the turbine prior to starting. Machines are designed as either hot, warm, or cold, depending on the length of time they have been shut down. In this example, a machine shut down less than 8 hours can be loaded at a rate of 20% per minute. A cold machine, which is a machine shut down longer than 24 hours, has a loading rate of 10% per minute. Again, refer to the turbine manufacturer's instruction manual to correct turbine loading rates. You know, that's once you have the machine up to operating speed, then you can start loading and go with it. And that's more of a compressor drive, pump drive, you know, when you're starting to increase rates on it, you know, when you're driving a paper machine, when you're at full speed, you're pretty much driving there. You know, I can adjust flows on compressors, you know, natural gas compressors, and I can increase the flow on them and bring the loads up and bring it down. And changing the load on the steam turbine requires the operator to change the speed set point of the machine. Increasing the speed of the turbine requires opening the steam inlet valves, resulting in increased steam flow, higher horsepower. Decreasing the speed set point closes the steam inlet valves. This is more of a multi-stage machine with control valves, control racks like your generator drives and stuff like that. You know, you can control loads by just jockeying your valve rack. A single valve machine like you got, not a whole lot, you don't control speed with a single valve machine. I've seen people try to do that. Ain't long they're ordering valve seats, because you can't control steam flow with a single valve. What we're gonna do, we're gonna put that over in it. Do not need valve. Turbines with hand valves require the operator to adjust these valves to correct throttle flow. Some of your machines have hand valves. A lot of customers call them power valves. 99% of them hand valves in the world don't work. The other 1% people don't know what they're there for. What they do, the nozzle block inside, which emits steam into the turbine, is set up in segments. And if you're not needing the horsepower, as much horsepower as you have there, and you just got excessive steam flow, you can go here and shut one of those valves, those little hand valves right there. You can close it, and what that does, it'll cut the steam flow off of one segment of your nozzle block. So that way you're not just blowing excess steam through there, it makes your turbine a lot easier to operate. If you're at minimum flow or minimum drive, and you've got so much horsepower, it's hard to hold the turbine in it for it to control right when you've got all that horsepower sitting there, you know. Hard to hold it back. Just these valves that correct steam flow, they need to be open to increase turbine horsepower and closed to increase the efficiency of the machine at low loads. Most people don't even know what they are, and half of them don't work no way, and then nobody wants to fool with them because they don't have handles on them, most of them. And it's so hot down there, you can't stick your hand down there. So, what people are doing now is doing away with those and re-rating their machine because they've established operating parameters and they changed the nozzle setup inside to dictate the horsepower and try to do it with a hand valve. If you are going to use those, we have air operators that you can put on, and you can just control it with air pressure from the handrail. You don't have to get over there and get a hold of it. Hand valves are most often located on the left side of the turbine casement when being viewed from the governor end. As the illustration shows, hand valve number 1 is on the lower right. If more than one is installed, they are sequentially numbered going in a clockwise rotation. I've had some customers think they're drain valves. Open them up, get ready to start turbine up, now I'm like, we got to open them drains, and well, we got them 2 open right there. So, well, how's that gonna drain? That's a foot off the bottom of the turbine. There is the example of water. Majority of operating problems result from impurities in steam supply. This is supplied to the turbine. These impurities cause deposits on nozzles and blades, which restrict steam flow and reduce the efficiency of the machine. They also accumulate on valve stems, causing sticking and binding. In severe cases, These deposits cause rotor balance problems as well as increased thrust movement. I got a machine down right now, got a crew over there working on a 4 megawatt machine, they can't get 2 out of it because the thrust bearing heats up. Pull the lead off of it, it looked like somebody threw a 5-gallon bucket of sheetrock mud in there. Just full, blades are full, just impurities in the steam. Picture on your left is the nozzle block, that's where the steam comes out of the case and into the first row of blades. You start seeing water and impurities come through there, you start seeing erosion in between those are drilled and ring nozzle ports and the nozzle block. They'll start cutting the bridges out in between them, then you end up with one big nozzle. Operating experience will allow and may dictate some changes in the operating procedure, especially that require time and speed to be used during startup. It is important that the operators can become acquainted with the normal operating conditions for their particular machine. Any changes from normal should be investigated and corrective action taken. You know, a lot of people go out there and start a machine up, and once it gets up running, like, that thing's online, we ain't going back around there. We had enough of that. And they don't go back to it until it quits. So, you know, it's a good idea for people just to, while the machine's running, go over and listen to it, watch it, see what it's doing, see what's going on. That way, when you walk by the next time, if it's doing something different, you're like, uh-oh. Run out of time, Kim?
Oh, you got another, what,
15 minutes.
another 15 minutes. When you get there first, you don't stop about 5-10 minutes early, you know, if you want to stop the next 5 minutes or so. You guys got some questions, maybe you want to have some discussion.
I just got a few more, you wanna get it
That's
covered?
fine.
These?
Let's go ahead and cover these, yeah.
What does an operator have to do to increase the load on a steam turbine? That's back to that, changing the load on the driven, that's pretty hard to do. Again, that's more of a compressor type, loading and unloading of pumps and flows. What causes the majority of operating problems with steam turbines? Lack of knowledge by our turbine operator, failures of theoretical components used to control the turbine, non-compliance with operating precautions for the machine warm up, impurities in the steam supply.
Like all that stuff. First one, get locked in all that too, like all.
Yeah. And it's, there's so many things that, contribute to it, you know, people think, man, I turned that over and that did that, and it killed it, well, it might not be just that one thing that happened, it's a basket full of them. Nobody knows nothing until something fails, and then here comes the fingers. Well, you should have done this and you should have done that, I know how that is. Well, 5 minutes ago, he didn't know how to get on turbine deck, now today, he's up here, he can tell me how to rebuild it. He must have stayed at Holiday Inn Express last night. Well, I can tell you by experience, don't tell the customer that, he don't like it. Shutting down the turbine consists of reducing the load, then slowly shutting off the inlet steam flow, till the governor valve is fully closed and the turbine rotor comes to rest. Although there are similar steps for every steam turbine, actual shutdown procedures can vary between turbine models. Always follow the manufacturer model-specific shutdown procedures for both the turbine and the driven equipment. A lot of times people go back and shut one down, they hit it, trip it. Well, you don't drive your car 100 mile an hour down the road and shut the ignition off, do you? You know, you kind of slow down a little bit before you know, it's better to go there and want to control the shutdown. Go ahead and shut the valve now, let it come on down to the speeds. It's something better than hit the button. You know, I'll shut that down on the way to break. When the steam turbine generator sits, well, need to look at that too. That's just telling you the same thing about bringing down a turbine generator. You don't go there and unload it, throw the breaker on it, and it's still on the grid. 'Cause, you do that, that's when you start seeing elevated cage temperatures and rotor temperatures. That's just like coupling failure on that turbine, unloading it right then, it takes all the load off right then. So see that upside down. Once the load is removed from the machine, activate one of the installed tripping features and observe that both the governor control valve and trip valve close. What's that? You know, once you shut your throttle valve down and the machine stops, you then trip it out. And that's another safety feature if something was to happen, you know, it's trip valve shut as well as the governor valve. As the machine is slowing down, make sure the auxiliary oil pump starts at the correct pressure. That's not there's a lot of machines being killed because of a pressure switch too. Auxiliary oil pump don't pick up. You come right on down, no oil. Yeah, you need to make sure that that picks up coming down. On 19, well, you don't have a gear driven oil pump, so you got a main over as you run all the time anyway, then auxiliary. So you don't really have, see what that pretty much, talks about is like a gear driven oil pumps that are mounted on the end of the turbo shaft. Once you get down certain RPMs, that's the end of that, and the auxiliary picks up. And you have a isolated AC oil pump over there, you just turn the switch on and it goes. You don't have to worry about really catching it on the pressure drop.
I think we got one on the vacuum truck.
Really? You can check that before you start up. That's one of them startup things, you know, you can start your main oil pump up and go over and reset your auxiliary and shut your main down and see if your auxiliary picks up. Make sure it operates good. To remove heat from the bearings, oil should be circulated for several hours after the turbine has been shut down or until the temperature reading of the oil entering the bearing is equal to the oil leaving the bearing. Oil must always be circulated any time the turbine is being rotated by a turning gear. Yeah, that's you don't have to worry about it, you don't have a turning gear, but I've seen people do that, bypass the interlock on a turning gear and latch it up, but they ain't turning 4 RPMs, but you got a 100,000-pound rotor turning with no oil. They think the turning gear is gone out, because the bearings are fall out. What is the preferred method of removing load from a steam turbine? By increasing the speed of the machine using the governor, by decreasing the speed of the machine using the governor, by tripping the trip throttle valve, by overspeeding the machine and have it trip offline. Be the second one, by decreasing the speed of the machine. The turbine generator says if the turbine load cannot be reduced to near zero, what should the operator avoid doing? Manually close the trip throttle valve. Close the trip throttle valve, open the generator breaker. That's what's number 3. Don't open the generator breaker. They're not real receptive to that. How long after the turbine shut down should oil be circulated? You asked that question early into it. Until the bearing, oil, inlet, and outlet temperatures are equal. But if you're not gonna do anything to the oil system, they need to shut it down. You know, that'd be the time you can save on startup, because there'll still be a little bit of heat in the bearings, just out of friction. So, it's better just to leave it running. But if you let it sit, a lot of times, any impurities in there, it just goes right to the bottom of the tank, and then when you go start up, here you go pump sucking up everything in the world, or you have deposits falling off pipes inside. And just better to keep it going through the filters, instead of picking it up and putting it down, it keeps everything in operating condition. Well, that's all of those. Y'all have any more questions I can maybe answer, or?
When we get like I said, when we get through here, we're gonna bring lunch by 11:30, so we're gonna have a little break here. After we eat lunch, we're going over the mill and go out on the machines on 19 turbines and 20. And, Laura talked about, it's gonna be kinda hard to hear over there with them operating, so just kinda play that by ear as far as talking about what you can talk about on the machine, what you can hear about. Then we will, like I said, we'll have opportunity to go back in, prepare for more conference room in there where it's quiet, and maybe debrief a little bit there, and then we'll go.